In software development, building software requires building executable programs and libraries from corresponding sources. This process is specified in build files, which direct the build tool on how to derive the target programs from sources. Among several build tools, Make is very popularly used. This is a Makefile that specifies the rules to build the main, sender, and receiver programs on a machine with either Java or C. Make presses the Makefile into two stages. The first stage is evaluation, where Make resolve all variable statements and rules into a set of concrete rules. In this case, Make will produce two sets of concrete rules, one if Java is installed and one if C is installed. A Makefile consists of rules. Each rule has a target file to produce, and a set of prerequisites. To build the target from the prerequisite, a set of OS shell commands called recipe needs to be executed. This stage is called execution. Now let's take a look at the evaluation phase. The first line assigns the path of Java compiler to variable Java comp. For Java installed machine, lines 4 to 6 are used to set the extension of source code and program files in compiler's command. Lines 13 to 15 define the program names that Make will produce. Lines 17 and 18 will be evaluated to prerequisite of sender and receiver to char. This function call will fetch all the data files from the current user directory, for example sample.dat. At line 20, Make defines install rule with sender and receiver to jar as prerequisites. Lines 22 to 24 defines a macro and $1 represent the first parameter. The for each at line 26 iterates over the variable executable and defines two rules via the execution of the macro. Lines 28 and 29 add a recipe to rules sender and receiver to char. Lines 31 and 32 represent an implicit rule, which is a template rule for any prerequisite whose name ends with .dat. For example, the rules sample and javaconf.dat are produced from the implicit rule. Due to the dynamic nature in Make, it is challenging to build the analysis tools for refactoring or code smell detection in Makefiles. First, name analysis of variables or targets is not straightforward. Since Make is dynamic, the variable's name or ID can be the result of evaluation of other variables. It's also difficult to distinguish between a variable ID and a string value. Another challenge is that one entity's name is produced from different code locations. For example, to rename the flex source at line 17, the dynamic locations include line 17, 18, and 23. That is, line 26 calls line 23, which is evaluated to line 17 and 18. Using text search leads to too many wrong locations. Second, automatic dependency analysis among the prerequisite targets is also challenging. Let's assume that a user downloaded or motivating Makefile and has a file named sender.dat in his current directory. Make will produce the following set of rules. Notice that sender.dat is a prerequisite sender.jar, and the rule sender.dat is produced via the implicit rule, and that creates cyclic dependency between the rules, which causes an execution error. This error is difficult to reveal, as it only appears if the user has installed Java and has that file named sender.dat. To address those challenges, we propose SYMake. SYMake symbolically evaluates the Makefile to build its symbolic dependency graph. Each of these nodes represents a target or a prerequisite. For example, install node corresponds to target install. Due to if condition, roll install will have two possible sets of prerequisites, either sender and receiver to jar or sender and receiver to all. Those two possibilities are represented by the select node. This symbolic node represents the returned value from the function called wildcard. Each SDG node refers to a V model, which represents the symbolic string value for the corresponding role component. For example, this block represents the V model of the recipe of sender to jar role. It consists of a concat node, which represents the string value being concatenated from its children nodes. Let's assume that we want to rename the suffix source to lib. You choose the new name, then SYMake renames it successfully and highlights all updated locations. SYMake also allows you to rename targets. SYMake detects code smells and errors in the Makefile, and lists all smells and errors and the corresponding line numbers and description. Double-clicking on a smell shows a detailed description about the smell and highlights the corresponding locations in code. In this case, a cyclic dependency is detected. For large and complex Makefiles, SYMake can detect many potential code smells and errors.